We talked about sort of classes and things like that. So we're going to back up and take a look at everything in terms of the Unreal Engine project structure, right? So you can see I've put a note here: actors, anything with transforms that can be placed into a level, components, materials, meshes, etc. This is the key thing that we're going to focus on when we sort of go forward in terms of putting our projects together, because the actor class and the pawn class are the two most important classes. You'll probably be using them quite a bit. Now, what is it? What is it? What does it mean that it's a class? Well, we'll get to that. But basically, we have projects, levels, sub-levels, actors, and components within those actors, right? So let's take a real quick kind of look at what that entails. So I'm just going to bring over a little work in progress, right? So the project is important to consider because, there it is. The project is important to consider because at the project level, you have certain things that you can set that will run a particular way for your entire project, right? Now, this is one of the big reasons why you want to understand the Unreal project structure, is that at every level of the structure, you can do some customization to it, right? So for example, at the project level, you can dictate sort of what default game mode your project starts in, right? So you can have a default launch as a virtual camera. You can default launch it as a game in a game mode, or you can create custom game modes that you can launch here for your entire project, right? So this means what your settings you set here will affect every single level, right? And you can dive down a little bit to the levels themselves, right? So inside each individual level, you get world settings that tie themselves to each of the different levels, right? So if I pop over here, I'm going to go into my levels folder, have a maps, right? So here I'm creating set 1, set 2, set 3, set 4. These are different levels that you can launch into, right? And they open up different environments, different characters, etc., etc. It's a container for a different experience. So you can have your exterior planet level, you can have your interior underground base level, etc., etc. And it operates as that sort of a container. Sub-levels, we'll not get into too much, but you can create mini levels inside of levels. It's this idea of a nestable asset. One asset can be nested inside another. But more importantly, I wanted to set up a project and level with you guys and talk about the actors. And inside the actors, I gave you a brief introduction to the components that you can use. And we'll talk a little bit about that today in terms of getting inside a blueprint editor and adding components to an actor. Now, what a component are just the bits and bobs that you put inside an actor that make up that actor. So if an actor is an empty container, you can say put in a door. And so the door is a mesh component, right? And you can put that in an actor. Well, then why not just take the mesh door and put it in your level? Yeah, but if it's inside an actor, you can add functionality to it. So you can move that door mesh component into the actor, and inside the actor, you can add a trigger to open that door, which you can't do by simply placing that mesh asset into the level, right? So this is where actors and components become really, really versatile, especially in terms of putting things together, right? Okay. Sorry?
Can you animate actors in the sequence?
Yes, you can animate actors. So actors can contain animation, but if you want to possess it, then you have to use a pawn class, right? So the pawn class has the framework that allows the addition of controllers, right? Sorry, not control. The addition of a possessible. It's a possessible actor, right? So it's not necessarily the player character. It could also be AI, right? So the game can take over the actor, right? So that's a whole other thing. Okay, so yeah, projects. Now there are a variety of different projects you can create, and I bombed through this real quick last time, right? But it's really kind of interesting for me because let's pop this open. One of the things that I've really kind of admired about Unreal Engine since its inception is the fact that it tries to make the process of creating a game as painless as possible, right? There's no sense in reinventing the wheel. From an art point of view, I'll give you an example. I used to know a lot of guys who were character modelers who were proud of being box modelers. Now, this was the thing, you know, the people would brag that they were a box modeler. They'd show a fantastic looking character and say, yeah, I modeled it from a box. Or, you know, they'll show like an amazing monster and go, yeah, that started from a cube. And I'm like, what's the point? What is the point of that? It just tells me you wasted days banging a cube into some sort of shape before you could actually start sculpting it, right? And I was a big fan back in the day of body part libraries. And it's not because I didn't know my anatomy. It's not because those of you who know me have seen my character sculptures, right? So I can sculpt characters. I just think it's a phenomenal waste of time to start from a cube. Do you know what I mean? To get to a bipedal humanoid basic shape, that's a waste of time. So I would take a body part library, piece it together. Obviously, once it's in place, I'm going to modify it like crazy and it's going to look nothing like the original, but it gives me a much stronger starting point to dive into. This is what Unreal Engine is doing, and that's why I love it so much, is that not only do you have project categories, you can create a games, film and television, architecture, on automotive, right? But if you go into games, it breaks it down into subcategories for you, which is fantastic, right? So we will come back and take a look at this as part of today's session. But you have these templates that have the architecture put in for a first-person shooter, flying, puzzle. Look at the sheer type of games that are available to you in terms of a starting point. You can simply swap out the geometry to start off with and use the existing sort of mechanics that are already in place. Now, obviously, I would want to see some sort of evolution of these concepts, but I'm not against this at all, right? I'm about against you guys using a template as I am, you know, my body part library that I mashed together to start building a character. As long as the character looks phenomenal, who cares where it started from? As long as the game is interesting, unique, innovative, I don't care what the underlying template is, as long as you've evolved it, right? So that's one thing to sort of keep in mind, right? But even with a blank template, right? If you pop into the blank template, you've got another set of choices as well in terms of how to set up that project, right? So for you guys who are in games development, you may choose to switch over to C++ versus Blueprint. Now, I'll talk a little bit more about the Blueprint scripting system in a minute, right? Because the two are identical. They're exactly the same. They're just two different ways of interfacing with the code. But we'll talk about that. So you can create a purely C++ project, which will bridge to Visual Studios quite naturally. So you can edit stuff in C++ if you so prefer, right? Then there's quality setting, right? So you can set it to maximum quality or scalable 3D, 2D. This puts in the sort of the structure to allow for scalability for mobile experiences and things like that. So for example, the LOD system will be modified slightly in favor of a greater degree of scalability. So the assumption that it'll be running on limited hardware, right? But let's be honest, guys, we all want to jack up the quality to maximum. It's fine. Ray tracing disabled. I leave it disabled because I haven't tested it, but the only comfortable hardware technology to work in ray trace mode is any RTX graphics card. Hence why I said it earlier. If you're deciding on a laptop, anything with an RTX card, you'll be all right. So desktop console, right? So here we can choose exactly what kind of target hardware. Now we had the quality setting here, but this just takes it further. So all the built-in systems around it in terms of delivering or packaging games or sending them or just creating an executable, right? You can set it to either deliver to desktop console or mobile tablet, right? In this case, we're doing desktop console. And then you have the ability to turn on starter content. I generally turn that off. You just get a bunch of deck chairs and a table. Like, you don't really need that. So no starter content, right? So those are the various different project settings. So you can see you've got a huge variety of content that you can make. So those are our project templates, target hardware, starter content. Oh, good naming conventions I'll talk about in just a second. Naming conventions are a massive thing, right? Because we have to be able to look at the files that we want to work with and identify them instantly. The easiest area to wrap your head around is textures, right? So the typical naming convention I would have for textures is T underscore as a prefix to say it's a texture, right? And then whatever it is, demon mask, and then underscore color for color map, or underscore AO for ambient occlusion, or underscore normal for normal map. Right? So that's a very simple naming convention. But information that's crucial in the pipeline is contained in that name, so that if I need to say run a batch operation on all the color maps, say maybe all the color maps that we've done for all the demon characters is way too dark, you can't see anything, right? So you have two options. You can go through and individually change every single color map, which is fine on a small game, but on a AAA game, that could be like hundreds and hundreds of texture maps. Or you could write a piece of code that just does a loop, looks for underscore color, and adjusts everything that has underscore color, right? So that's why naming conventions are absolutely vital in a production, because you can do these large batch operations by adhering to these naming conventions, right? Okay, levels or containers for scene actors. This idea of container is really sort of interesting. It's hard to wrap your head around in the beginning, but it's very, very important, right? What that means is that everything that you use inside of Unreal is effectively a container that you can put other bits of data in, right? And we'll talk a little bit about that. Actually, I'll show you a quick example, right? So if we come in here, let's say if I were to, so this is our level, and it's a container that contains everything that I've outlined in the world, right? But if I were to come in and let's go into a blueprint, right? So if I go into a blueprint here, this is another container, right? This contains not only the scripted functionality of the camera that I built here, but the viewport as well contains the assets. And it's all inside this self-contained kind of black box, right? And so a lot of the elements in here operate as containers, right? Let's move the set helipad up to the front here. Yeah. Okay. The world outliner. We'll get back to that. Yeah. Okay. So actors within Unreal Engine can be described as a reference instance of the engine classes. These could be, but are not limited to, sounds, static meshes, skeletal meshes, blueprints, cameras, lights, volumes, more. Well, let's investigate this, because as complicated as it is a concept to wrap your head around, it's incredibly valuable to understand what Unreal has given you, right? So I'm going to right click here and I'm going to create a blueprint class, right? We went through this whole rigmarole briefly about how the actor is the base class, and then each one sort of builds on it, right? But if we take a look at all the classes that are available to you, right? We can go in and see what basics are built into the class that are modified and built out to give you more. So did I give you guys the dog example of how classes work? I had a Lassie collie dog, and then I had a Chihuahua. Yeah. The same thing with vehicles, right? You can create a vehicle class that's got a driving wheel and a gas pedal or petrol. Do you guys call it? No, you call it. What do you call it here? Just accelerator, gas pedal. Yeah, accelerator. Gas pedal. So you can have accelerator, brake, right? But that's cool. You can instantiate that class because to make a truck, because a truck also has a steering wheel, accelerator, and a brake, right? But then you can add truck specific things to it. That's basically what it is. Aaron? No, I didn't say your name. Okay, so that's basically how classes work. So the actor class being the base class, you can also see what has been given to you, right? So we've got, you know, a whole bunch of, there's a few that I don't quite understand what's happening, but we can see the sky sphere and sun position are based on the actor class. We get, you know, color correction class. We've got a whole bunch of different classes all built on the actor class. And all of this is callable. You can access all of this. Now, do you need to memorize all of this? No. One of the things that you will find working with things like code or blueprint scripting is you will become much more familiar with technical documentation. Now, don't freak out. Just because it's called technical documentation doesn't mean it's hard to understand. Oftentimes what technical documentation is a list of functions and what they do, right? So you'll be referring to it and going, okay, well, I need something that, you know, helps me with AI pathfinding, right? And you can look through the technical documentation and you can pop in those search terms and it'll show you functions and what they do. So all of these different extensions to the actor class, you'll be able to find in Unreal's documentation, right? But there's a sheer amount of tools just in the actor class alone. VR editor, teleporter, things like that, that are just built on the actor class. And, you know, again, those are all exposed to you and available to you, right? Okay, so that's that. Components and UI, right? Oh, I don't want to go through the UI stuff. The UI stuff, I think it naturally makes sense after a while, right? So we got our world outliner, which is a grocery list of everything we put into our level. This is what I was talking about the starter content, by the way. A couple of chairs and a table, right? You don't need that clogging up your hard drive. And then we've got the details panel I talked about, content browser, etc. We'll get intimately familiar with that. I won't go through navigation as well. That just takes practice. You can't really talk through navigation, right? So I'll talk a little bit about that. Some key hotkeys here that are important. The F to frame is probably the one you will need the most when you get lost, right? So when you're kind of navigating around your scene and you're just like, oh my God, where am I? You can click on something in your world outliner. Just say, okay, I know where the helicopter is. Hit F, it'll focus in on the helicopter with the added benefit that that helicopter will be the center look at point for your rotation, right? So that F key saved me so much when I was learning Maya, when I was learning XSI. The F key seems to be common. I think the F key is, yeah, it's the F key in ZBrush as well. It just quickly pops whatever object you have selected right dead center of the screen, brings you really close to it, and it's a fast, easy way to orient yourself, right? Okay, so alt left mouse button to tumble orbit. Yeah, that's all basic stuff, right? What you guys might want to do is what I generally tend to do when I'm learning new software, whether it's Houdini or Blender or whatever, is I'll just have post-it notes on the bottom of my monitor with all the most convenient hotkeys for navigation and manipulating objects, and away you go. It just becomes a lot easier to, after a while, your memory kicks in and you don't need those post-it notes anymore. Okay. At any point in development, you can use the play in editor button to test your application. Okay, so we'll talk a bit about that. Right? So let's pop in here. So with this particular scenario, right? Actually, you know what? I'm going to flip over to, let's open up a blank project, right? I feel a little bit more comfortable walking you guys through a blank project. That way, because there's a lot of built-in complexity that I don't want to go over. So let's start there before I get into the difference between launching runtime and so in editor, right? Klobazam makes me like a flipping space cadet. Sorry, Aaron, you're going to have to spell that out for me. I thought I heard my name. The Klobazam makes me like a flipping space cadet. Oh, is that the COVID vaccination? It's called Klobazam. Never mind. Moving on. All right. So I'm gonna pop open Unreal. And we'll take it from there. Any questions so far while Unreal Engine is opening? There shouldn't be. It's just basic stuff. So once Unreal Engine pops open, why is it taking so long? Watch it. I'm going to double click on it. Watch it. 3 instances of Unreal Engine will open all at once. I'll bet. While this is opening, I can talk a little bit about, what is the best engine, right? And I've had the benefit of having worked in 3 of them. Three of the ones that are just sort of pre-built and available: Cryengine, Unity, and Unreal. I've worked in a few others, but they were more bespoke, proprietary tech from the different companies I worked at. But my favorite was Cryengine. Just in the terms of the way it organized how you worked. It had an inbuilt layer system, which was really, really cool. But that's speaking to a legacy of way of working for me, in that I needed to transition quickly to node-based thinking as opposed to layer-based thinking. Well, Unreal Engine's blueprint system is node-based, so I've gotten kind of more accustomed to that. Unity, I found, was interesting because its UI was very light. It's very easy to get into, right? And it was comfortable. By contrast, Unreal Engine's got a lot going on in its UI. It's like information overload when you first start getting into it. Back in the day, Unity, I don't know what it's like now, but Unity was driven by C#, which was good for me because I was doing some C# stuff with XNA Game Studio, which was Microsoft's thing for a little while. It was super fun. They had an XNA framework thing where you could write C# code and create little games, and you could actually launch them on a retail Xbox. That was super fun. They didn't unlock all of the features of the hardware of the Xbox, but you could build like 4 meg or 8 meg games or something like that. So that was kind of cool. So the transition from XNA Game Studio to Unity was a little bit of a smooth one for me. Although ask me about anything C# now, and I'd probably be like, oh man, I forget everything. But that was an interesting experience as well. But I've firmly kind of landed in the Unreal Engine camp just because of its usability, right? And a lot of the features that are available. Okay, so let's start off by creating a new project, right? And we'll pop into the games project. Now this time, I'm gonna drop into a template. So we're gonna take a look at the 3rd-person template because that'll give us something objective to look at in terms of character animation, right? So we'll pop into next. We'll make it a blueprint game, maximum quality, ray tracing disabled, and I'm going to put this in delete this game, and I will call it 3rd-person. I think we're 4. Oh, project names must not be longer than 20 characters. Yeah, occasionally you run into this character cap. I hate it so much. It's a Windows limitation. There is a way of turning it off, though. But I can't remember off the top of my head how to do it. Okay, 3rd-person, lecture 4. Yeah, we'll do that. So this will give us a nice bare bones sort of structure, which we can take a look at and analyze, that kind of a thing, right? In terms of learning resources, I'm a big fan of deconstructing stuff that's already out there. And I bring this up because there are a lot of templates also available on the Epic marketplace, right? So I'm gonna open up the Epic launcher, just keep that open on the side. Okay, so I'm gonna set up in the content browser. Get back out of here, quick sec. So here we've got the 3rd-person template. Some of you guys are intimately familiar with this, right? So it's got the bare bone structure to kind of get you going. I wanted to pop in here just to kind of go through the next concepts in the slide. One of them being this idea of an executable state or a runtime state and being in just the development kit, right? Now, the reason why I wanted to sort of emphasize this is sometimes you will forget. There are certain things that work when you're inside the editor, or actually, more accurately, there are certain things that won't work unless it's executed at runtime. Primarily speaking, the blueprints. And I think I talked this through last class when we built the flickering light. The flickering light does not work because it's in a blueprint. And the blueprint is driven by an event. And that event is playing the game, right? So there are certain things that we will build that will not operate until you hit the play button, right? Now, when you hit the play button, Unreal will just pop you straight into the game, right inside your level editor, right? Woohoo! But what I prefer to do is to do a new editor window PIE, right? So what this does is it'll create a brand new editor window for you, right? And what I generally like to do, if you got a dual monitor setup, is to set this up on my secondary monitor, right? Or if I'm working in the living room on my big TV, which is super nice. And I love it because this allows me to look at the game experience separate from the editor. So when I look over at the game window, I'm totally in the audience mindset. I'm just like, okay, so this is the experience the gamer has, right? And even if you float it in the same window, just that, or in the same monitor, just the fact that it's in a separate window breaks you out of the developer mode and into audience mode, which is really sort of important for evaluating your games, right? So I recommend you guys get used to playing in a separate editor window. Also the fact that if you just play in your selected viewport, you might occasionally forget that this is the gaming experience because you have the gubbins of your UI around you and you're not in the proper mindset, if that makes sense, right? You must always step back and gauge the emotional experience of what it is that you're building. That's really super important, right? Okay, so man, all that setting up of the third person editor just to talk a little bit about that. Oh, and the hotkey is Alt P, which is cool. Let's give that a try. I did not know that that was a hotkey. Alt P, sweet, and then escape to come out of that, right? Oh, yeah, before I go into the content pipeline stuff. So a few other things to point out as well, right? So it played in the window because it will play the last one that you've selected, right? So I'm going to select new editor window. That's cool. So when I hit Alt P, I should get a new editor window, which I do. That's cool, right? The other thing is that the display inside of Unreal allows you to view not just your character asset, your environment assets, and but your cameras and all your helper objects as well, right? So we've got our, what do you call it? The spawn point for when the player comes in, which is, so that's the arena, the walkway, the lighting, and third person character, right? And that's the blueprint with the camera attached and the player start position in there as well. We'll take a look at that in a second. You'll see that little mini camera preview window opens up for us here. This is because the type of camera that is attached to this character is likely a cine camera actor. It's a special type of camera. We'll talk a little bit about that later. But the one thing I wanted to sort of point out is that we have all of our game icons. Now, if you hit the G key, those disappear. So to add to the confusion, you have a mode where you can take a look inside your editor at your level without all the game icons, right? So this is another reason why I think it's important to set up your play button so it opens up in a different window, right? Because I'm still in editor mode. I've just hidden all my game icons, right? And this is nice if you just want to sit back and evaluate the environment you're building or the character that you're texturing, and you don't want to have all the garbage in the way. So that's G for game icons, and you can toggle them on and off, right? There are a few different view modes that you can play with up here as well. So in here as well, if you don't want to just hit the G key and get rid of all the game icons, you can go through and be a little bit more specific about it. You can say, okay, well, let's get rid of the widget components, or actually not the widget components, but well, I'll just show you actually. You can turn off your static meshes, right? That'll get rid of those guys. You can turn off your skeletal mesh, which will get rid of your character. There's various different things you can turn on and off. You can turn off, wait, we don't have a landscape in there. PSP objects? No, that's static mesh. Okay, that's cool. But you've got stuff where you can turn off flags for how your post-processing works. I don't know if there's a post-process volume in here. So if you've got light blooms or lens flares, you can turn those on and off. You know, light types, you can turn off your think there's a point light in there. That's a directional light, right? So you can turn it on and off just to check what it's doing in terms of contributing to the scene. Lots of different stuff you can turn on and off in here, right? So we have various different view modes. We can look at lit, unlit. We can look at brush wireframe, which is super handy if you want to see what your polygons are doing, right? You can see that inside of a game engine, all quads are instantly tessellated, right? So, which brings up the question, why do modelers model in quads if everything gets tessellated in the long run? That's something I'll leave with you guys, right? And you can take a look at lighting contribution, right? Et cetera, et cetera. Reflections, right? So I'll go back to lit mode. Here you can change your different camera views, and you can switch to your cinematic viewport, which will automatically grab your cinematic camera in here and display that. So if I switch to cinematic viewport, that's from my third person default camera, right? So I'll switch back to default viewport. And in here, we can turn on things that we need in our HUD display. One of the things that you might want to turn on is show FPS, which is frames per second, right? So that's an important display to have because then you can assess the quality of the experience in terms of frame rate and where you might need to optimize areas, right? Okay, so back to my question, right? If a game engine tessellates everything or triangulates everything, runtime, why do we model in quads? Just curious if you guys know. Nope. It has to do with an aesthetic consideration. Oh, somebody guess? Somebody gonna guess? Well, okay. Well, it's just that with two triangles, there's more of a tendency to have a shear or a bend and a difficult light calculation across the border, right? So basically, just having two coplanar triangles, the visual artifact that you get from lighting is a lot smoother, right? So again, it's more of a visual thing for artists and sculptors in terms of working with flat planes, right? It's a lot easier to wrap your head around in terms of getting quad strips to evenly sort of capture light and shadow across that strip. Whereas if you had a tri-stripped or a triangulated piece of geometry, it's a lot more difficult to try to balance the light and shadow across all of those different edges. And it is sort of hard to explain, but if you're curious, I recommend you try to model a character completely in tris one day. You know, it's quite interesting. You'll find it incredibly difficult to do. And then when you convert quads to tris, the conversion almost always happens smoothly. If you've got really good quads, it'll triangulate nice and smoothly and everything will be good, right? It also had to do, back in the day, we had to be very, very careful with tri-stripping. So there are many times when I was optimizing a model where I'd go through various quads, and if we have a quad and the sort of division was this way, I would flip that division, right? Just to get the tris to do what's called concertina. So you'd want that, if you're looking at a triangulated version of your mesh, you wanted the triangles to kind of intersect in a concertina pattern. It had to do with how I believe the Vertex Shader pipeline processed geometry, but you don't have to worry about that anymore, right? From what I hear, tri-stripping is no longer an issue. So it could be part legacy as well. You don't have to know all the stuff I just talked about. It's just for me to relay a little bit of the technical history behind why people model in quads. And I'm sure anybody else out there watching knows a gazillion other reasons why we model in quads, but those are the ones that I remember from when I was in the industry, right? So, and you just get better geometry if you model in quads. Okay, so the other thing I want to talk about in terms of the views is the idea that we can come down here and turn on certain stats, right? Now, what the stats do, they help us to sort of optimize a game. I feel like I've gone through this already, except inside the console, right? Where you can open up a breakdown in terms of how the GPU is calculating your frames, your draw calls, etc., etc. And you don't need to know that just yet. That's more towards the end of development where you have to go through and you got to really figure out, why am I dropping down to 10 frames a second in this one area? Well, you might want to pop up these different sort of meters and heads up display to see exactly where your frame rate is dropping, or the GPU, the draw calls are dropping below a particular millisecond per frame. You can see that here. And it can just help you evaluate your level a lot easier. Now, I'm a big fan of having any kind of diagnostic HUD display up all the time. Oh, I ran into this issue yesterday where I turned on the detailed stat and I went to toggle it off and it turned off the frames per second instead, but it left the detailed count. So the way I needed to fix this was to hide everything and then come back and go to my stats and then bring up my FPS, right? So I like to have a little bit of something going on the HUD display to kind of keep my mind focused on not going overboard. And the bare minimum of frames per second would be good. You know, inside of Maya, I generally tell you guys to turn on in the HUD in Maya your poly count, so you can keep an eye on your poly count. It's the same kind of thing, right? So yeah, that's the heads-up display and some of the display items that can kind of help you in your work, right? All right, so content pipeline. All right, so system units. This is going to lose a lot of you because it's a difficult concept, I think, to wrap your head around. And I believe the difficulty lies in the fact that we grow up learning a particular system, whether it's the imperial system or the metric system, and that's how we learn to break out units. Now, the thing about packages like Unreal or Maya is they give you Unreal units or Maya units. And what the heck does that mean, right? Well, they basically give you a square and say, that's a square. You tell me what that is. Is that a centimeter? Is that a millimeter? Is that a meter? It's up to you. You just tell me what it is, and I'll change the math for everything to support that, right? So when it comes to things like Maya and Unreal, the first thing you got to do is sit down and decide what unit you want to work with, right? Now, the default in Unreal is centimeter, and there are reasons for that, right? So the default centimeter setting is built because it's the most convenient to deal with a realistic human sort of proportion, right? So the height of an average male is 1.75 or so meters tall, right? So the centimeter unit is the most convenient to deal with that character's perspective on all the it's like the medium measurement to deal with the smallest possible object and the largest possible object. So we can have a handgun that's in centimeters. We can have a vehicle in centimeters. Building, it starts to get a bit crazy, but we can still kind of deal with it in centimeters, right? It's just a comfortable unit. So when we take a look at something like building an automatic rig in Motion Builder or an automatic character using HIK inside of Maya, the default units is centimeters for all the mathematics, for all the procedural operations that happen. Now, the other important unit is meters, because unfortunately, most physics engines on the planet that deal with mass destruction and things like that, or even cloth simulation and hair simulation, like to default to 1 meter units, right? So that adds a layer of complexity, because once you start doing visual effects simulation stuff inside Maya or Houdini, you got to simulate in meters and then do the mathematical calculation to convert everything to centimeters. Thankfully, I think it's just one node that you place at the end of the chain that does all that calculation for you. But it's just one of those things that you have to deal with. So generally, there are a lot of things that an art team determines when they meet for the first time. One of them is naming conventions. The other is scale. Now, here's why scale is important to understand, right? Because you have to make sure everything in your content pipeline follows that scale. ZBrush, Motion Builder, Maya, Unreal. You have to make sure, first of all, that everything's Z up and that everything's operating on 1 centimeter scale, right? So the player character is 192 Unreal units tall, so slightly bigger than the average male. That's cool because, you know, it's a video game. Everything's bigger than life, right? By the way, just a warning, ZBrush messes with scale so much. I still have yet to figure it out. I've been trying to figure it out for years now, but nothing that I seem to, no sort of mesh pipeline that I seem to put together that involves Unreal can solve the scale issue. Right when I figure it out, I'll export a guy from ZBrush, get him into Unreal, and be like, oh my God, it's a giant. What happened? And then so you try to compensate for whatever X number of units that the character scaled up, and then you go into ZBrush and you export out again, and then the character comes in that small. I'm like, what is going on? So something about ZBrush. I'm determined to figure it out, but something about ZBrush, the way they scale assets, be wary of that. So my only workaround is every ZBrush asset I do ends up in Maya first before going to Unreal. That way, I mean, it just makes logical sense anyway, because there's a few things I need to do to it inside of Maya, whether it's rigging, whether it's, UV unwrapping or doing final textures or whatever. It generally ends up in Maya anyway. And then I can export out from Maya and know that it'll come into Unreal fine. Okay, so importing meshes. Now, there are two different solutions here, which I'll talk a little bit about. I don't know if these guys go into it. Quixel Bridge. Yeah, I don't think the Unreal website goes into it, but it's very, very important to consider. So let me, we're almost at 11 o'clock. Would you guys believe I got all these screenshots from a very, very short video, and I'm just turning it into like this hour-long kind of diatribe? But hopefully it's all good stuff. It's all stuff that you guys need to know. Okay, so let me pop in. It's really important that I talk a little bit about how Unreal Engine deals with assets. So I'm going to do this by going into one of my Viz projects, and we will take a look inside the content folder, and let's take a look at the cast folder. Okay, so perfect. Oops. Okay, let me open up another Explorer folder. This again has to do with organization. I know something you guys don't like to spend a lot of time thinking about, but it's so crucial. So I'm going to pop into my content folder here, right? So in the left-hand Explorer window, I have my content folders. This is where I build my geometry. This is where I store my props, etc. Where did my characters go? Or are my characters... Are they in my global folder? No. Oh yeah, okay. This is a great example of an organizational scheme that got out of control for me. But I'll walk you through exactly what's going on. So initially, I was creating previs, right? So I created assets for previs, and then partway through, I was being asked to do more and more and more and more. And I was like, okay, I need to create a global folder that has all these assets so I know where to get them. This is one of those things that happens when you change a project structure mid-project. You're just like, you end up going, where did I put those assets again? So here in my previs folder, here's where I created my temp assets. And I ended up needing them later, further on down the line. So this is an area inside my hard drive where I do all my work, all my ZBrush work, all my Maya work. But in this case, I've got a digital double library because the VFX supervisor didn't want me wasting months sculpting. It's just like, just use some stand-ins, right? So I've got some base geometry proxy people here, right? So these guys are in Fbx format. The Fbx file format is the de facto geometry interchange file format. Everybody exchanges in Fbx. Occasionally we use OBJ, and I'll talk about the differences between the two in just a second. But Fbx is the universally accepted standard in terms of exporting and importing geometry and animation, etc., etc. Now, inside Unreal, everything that you convert in, or everything that you import into Unreal gets converted into a U asset. So it's still an FBX for all intents and purposes, but it's been converted to the Unreal Engine file format. Now you can do one of two things, right? You can import the asset from where you have it in your content folders. And when you import it in, it will automatically convert it to a U asset when you bring it in, right? And every time you update this asset, it will automatically detect it and update it here. Or you can export your FBX directly into the content folder like I've done here. It will directly convert it to whatever asset you need here. The benefit of this is that you constantly know where the FBXs are going. They're going right into your content folder. Now, the disadvantage is that it will build up over time. But when you finalize your game, it will strip out all the extra FBXs and it will only use the U assets anyway. Right? So two ways of organizing yourself. You can have your FBX files located somewhere else and import them in, or you can just, from your content creation package like ZBrush or Maya, export directly into your content folder. I prefer this, right? Exporting directly into the content folder, just because I know exactly where, well, I set up my exporter once and I just have to hit export, and I know that it's going to be self-contained within the project. So if I had to take this whole project and bring it somewhere, I know that the FBXs will be in here, right? So those, yeah.
How does, because I know you get a lot of import settings.
Yes.
When you're importing something, how does it then, if you're exporting straight into Unreal, how do you access those settings?
Oh, it'll pop open the import settings inside of Unreal, okay. Right? What Unreal does is it auto detects any changes in the content folders, right? So I'll show you an example, right? So let's open up one of these guys. We're just debating whether or not to open ZBrush. Whoever will open quicker. So actually, this is good. I'll show you how the Fbx pipeline kind of works for static meshes. Now, this is a good sort of segue because there's also an Fbx pipeline for animation, which layers in a little bit more complexity than what I'm about to show you here, right? So it's good that we start off with static meshes. It's nice and basic. We can start there, right? I'm being asked a load of Unreal Engine questions from the one group of guys who I thought didn't need any answers already. I mean, aren't you guys like way ahead? You're like almost finished your second game or something?
No, I was just wondering, because like, if it was I personally think, like, I like having all my assets in like one folder, separate everything else. Like,
yeah, I agree with that. You know, that's I gotta again preface what I'm saying or caveat what I'm saying by saying this is my own preferred workflow. There's not one right or wrong. There's a lot of times where it's not just other guys as well. Sometimes myself as well. I might start a project and go, you know what? For this project, I want to keep all the FBXs contained in an external content folder so that I can very quickly send the base meshes to an outsource company or somewhere else. So in that case, I wouldn't export directly into the content folders. But for a personal project, and I think that's the difference actually, now I'm talking it out loud. For a personal project, I like to export directly into the content folder because with personal projects, they're relatively small in scope. I'm not doing anything complicated, right? I don't have to liaison with a bunch of people. So in that case, I might just, set up the exporter directly to do that. Right? Okay, so it's not drag and dropping. So I'm gonna have to go in through my ZBrush plugin, go to my FBX import, and let's import that guy in. And I'm just gonna copy paste this directory so I can get at it quick. And we'll do man with a hand in his pocket. Okay, so P. So this is the asset. Okay, so let's say we're done our sculpting, right? I'm just gonna, right, here's our guy. And we want to export this out, right? So Oh, I should have done this in Maya so I can show you the Maya exporter, but that's okay. So I'm going to come in here. Now that I've got my finished geometry, there's nothing attached to it, no textures, no materials or anything like that. I'm just going to go over to my Z plugin and then Fbx Export Import, and I'm going to export this, right? Now, the way I'm going to export this is I'm going to send this directly into my engine folders, right? So I'm going to go into where I've got my production design, viz, previs, VR, star chamber, and into the content folder and in the cast folder, right? So you see I've got one stand-in already. So I'm going to make this stand-in 2, right? So now there are various options that we can set for the exporter in ZBrush. Actually, let me do that. I skipped over this step. So we've got a bunch of options that we can set for the Fbx exporter as well, right? So we can export cameras, which we don't need. And we can export smoothing levels, polygroups, et cetera, various different things that we can add to this export. We can also choose to which version of the Fbx exporter we want, right? By clicking here. So there was a while where the Fbx exporter was really quite volatile. And so you had to specifically select, oh man, I went around the bend. You had to specifically select which Fbx exporter you were using, but by 2020, that all leveled off, right? So there's a lot of legacy stuff built into the Fbx 2020 exporter. Basically, you won't have a problem exporting out as Fbx 2020, right? And then you can choose as a binary or ASCII file. That's fine. You can leave it like that and then just export, right? So I'm going to go back. Hopefully it remembered my copy paste. No, it didn't. So I'm going to pop back to here, grab this, copy, and paste that in there. And I'm going to export this out as stand-in 2, right? And away it goes. And what will end up happening is, oh no, it's not this. It's not this one. It's in this one here. Okay, there we go. So instantly, Unreal Engine will sense the change in the content folder and pop this open for you. I didn't do anything. This window just popped up, right? And then so here is where you can define, okay, it's a skeletal mesh or not. In this case, it's not, right? And you can set a few different things, right? There's not anything that, everybody uses MIC-T space in terms of normal generation. We don't need to import transforms. Material, you might want to choose which material you want to import, but that's fine. And then the Fbx version, and then import all, right? So what ends up happening when you do that, right? We will, one sec, I'll close this guy up. We'll go back into the scene and we'll go back into our content folder under cast. You can see that I've got stand-in number 2. He's come in, right? And then if we look at our content folder as well, you can see that the Fbx is there as well as the U asset. Remember, this is in the Unreal Engine content folders, right? So I've exported directly in here. It's automatically converted it for me, and it's added it here for me. And then I can just pop him, place him in the shot, right? However many instances of the guy I want to place in the shot, right? Just as a kind of anecdote for you guys, oftentimes you'll have sort of difficulty creating scenarios like this just in terms of scale, right? So this is an Augusta helicopter, and I had a hell of a time trying to figure out how tall is the Augusta helicopter compared to a human. So, and that's something that's sort of important in terms of what I said earlier. Scale is going to be one of the #1 issues that you don't want to think about because you don't think it matters, but is like hugely important later on. So, yeah. So does that answer your question or show you what that's like, that whole process? That's it. That's the Fbx pipeline. It's really dead simple for static mesh. Now, when we start talking about the FBX pipeline for animation, it gets a little more complicated, but not that much more, right? So we'll talk a little bit about that as we go forward. I'm trying to find where those notes are, right? So that's importing meshes, right? And again, the auto update feature for me is a godsend. I love it, right? That means all I have to do is work inside of my export FBX, boom, it automatically appears in the game, right? Okay, so is that Quixel Bridge? I think I've talked to you guys through Quixel Bridge a little bit. Have I?
Yeah.
Yeah. Okay, so I won't spend time on that. A fantastic resource. Static mesh editor. Okay, so I think the next few are talking about meshes. So, any questions so far, by the way? Okay, that's cool. I'm not going to do a live example of this. Oh, crap. Hey, guys, we're at 11 o'clock, right? So I'm going to end it there, and then we'll come back and we'll talk a little bit more about, well, we'll continue through this sort of basic run through. I'm going to try to squeeze in the animation pipeline for you guys so you guys can see how to get animated characters in as well, right? So that will happen in the afternoon session. Okay? Any questions? Nope. Okay, all good. So I'll check back here with you guys in an hour. Oh, before you go, let me grab a quick attendance. I forgot to do that, right? So let me pop over into the attendance module. We'll take that real quick. And then you guys can take off. All right.